All right, so these are the solutions to the three equations that's on worksheet number 3. Notice that equation 1 is a cubic equation, so it's a polynomial equation. Equations 2 and 3 are square root equations, and so we're going to solve these differently than we solve number 1. So when solving this equation here, notice there are 4 terms. It is in descending order, and we do have 0 on the other side. And the way to do that, since this is a cubic equation, a polynomial equation, we're going to attempt to solve this equation by factoring. So I'm going to use factoring. Okay, so we're going to solve this by factoring. Now, when solving this by factoring, you're going to, and notice there are 4 terms. So you're going to try and group. So we're going to, by factoring, in particular, grouping. So we're going to try and group the first 2, and we're going to group the second 2. That's normally what's going to happen. Sometimes you're going to have to rearrange terms, but for us in this case, since it's in descending order, chances are you're going to group the first 2 and then group the second 2, okay, or the last 2. All right, now from this first group, you have to recognize that I can, in this case, you have to recognize that you're able to find a GCF here that's something other than 1. So notice that in these 2 terms, you have terms with the variable x. This is being raised to the 3rd power, so this term has 3 factors of x, and this term has 2 factors of x. So the greatest common factor will be the one with the lowest list of factors. So in this case, the lowest exponent. So it'll be x squared. So you're going to factor out an x squared. So when I factor out an x squared, I'm going to get x squared times, and you're going to have to figure out what's going to go inside this parentheses here. So the idea of the distributive property. So x squared times what will give me 2x cubed? Well, that's going to be 2x. And that kind of makes sense because x squared times 2x is 2x cubed. When you multiply like bases, you add exponents. 2 plus 1 is 3. Minus, over here, x squared times what is itself? Well, x squared times 1 is itself, right? Okay. Then we're going to now look at the second group. So look at the second group. Notice this is a positive right here. If that was a negative, you'd factor out a negative. Okay, so keep that in mind, but it's a positive here. So in that second group, if you look at these 2 terms, what they have in common, the greatest common factor, is a 4. 4 goes in a, 4 goes in a 4. And so you want to factor out a positive, whatever the sign is, which you're going to factor out. So you're going to factor out a positive 4. So you're going to say plus 4 times, and then the same idea you did here. 4 times what is 8x? So that's going to be 2x. All right, the distributive property. 4 times 2x is 8x. Minus, and then 4 times what is in this case a negative 4? Will be negative 1. Now, if you're doing this correctly, if it is factorable by grouping, then these expressions that you have inside the parentheses should be the same. Okay, so in this case it is. All right, so you're on the right track at this point. Equal 0. Just make sure you say equal 0 because these are equations. Now, what you want to do next is, again, notice that those 2 expressions here are the same. So now what you want to do is factor that out. So basically you're going to say, I'm going to factor out 2x minus 1, and then I'm going to write as a product of whatever's left. So if I take out 2x minus 1, you're left with x squared. If I factor out 2x minus 1, you're left with 4, positive 4. And that's going to equal 0. So notice this expression right here is exactly the same as this one. And it kind of makes sense because look, if I take x squared multiplied by this, that's this. If I take a positive 4 multiplied by this, that's this. Okay? All right, now at this point, that's where you want to use the 0 factor property. That's what you want to use next, the 0 factor property. And so the 0 factor property says that if you have 2 or more factors whose product is 0, then one of those has to be equal to 0. So now what we're going to do is we're going to set each of those equal to 0. So I get 2x minus 1 equals 0. and then x squared plus 4 equal 0. And so notice I went from a cubic equation to a linear equation and a quadratic equation. And the linear equation is easy to solve for. You can add 1 to both sides. So I get 2x equal 1. And then divide both sides by 2. I found one of my solutions. One of my solutions is 1/2. So there's one of them. Okay, now to solve this one, the best way to do that is to see there's no x term. All you see is an x squared term. So the best way to do this one is to bring the 4 to the other side. Get x squared by itself. So I get x squared equals a negative 4. All right, now I'm going to go ahead and rewrite this. The next thing you need to do, remember you're trying to get x by itself. Well, right now I'm squaring x. The opposite is to take the square root of x. But remember, when you take the square root of both sides of an equation, you're going to have to remember you need to put the plus or minus. All right, so plus or minus square root of a negative 4. So then the square and the square root undo each other, and you get plus or minus. Now we got to think about the square root of a negative 4. Now remember, the square root of a negative number is not a real number. It's an imaginary number. And you learned about imaginary numbers. You have to remember that the square root of a negative 1 is defined to be I. And we know that the square root of 4 is just 2. Not the square root of 2, 2, because 2 times 2 is 4. And so therefore, the square root of a negative 4 then will be the square root of a negative 1 times the square root of 4. And then the square root of a negative 1 is I times, and the square root of 4 is 2, and we rewrite this as 2i. And so then this becomes plus or minus 2i right here, and there's your solution. Now, you can, if you want to, notice there are 3 solutions. One's a real number, 2 of them are imaginary solutions. One's a real solution, the other 2 are imaginary solutions. So you can leave it like this, or you can say x equal 1/2, x equal 2i, x equal negative 2i. So these are all different ways of writing the solution. But you at the end, you needed to recognize that I had 1 real solution and 2, right here, plus 2i, negative 2i, 2 imaginary solutions. All right, so that was number 1. Okay, now let's look at number 2. In number 2, we had the square root equation, the square root of 3x minus 1 equal 4. Now to solve a radical equation, and this is a square root equation, you want to isolate the radical. You want to isolate the square root, which it already is. So I already have the square root of the square root expression by itself. Now, remember, just like we did this one, where we had x squared equal negative 4, we're trying to get x by itself. The opposite of squaring is square root. So that's why you saw me take the square root of both sides. In this case, right now I'm square rooting. I'm trying to get x by itself. So I need to get rid of the square root symbol. The opposite of square rooting is to square both sides. So I just rewrote this over. So I'm going to square both sides this time. So notice the difference between these two. And then the square root and the square undo each other, just like we did here. And you're left with the radicand, which is 3x minus 1, equal, and then 4 squared means 4 times 4, which is 16. So notice I went from this radical equation, the square root equation, to a linear equation. And then I'm going to solve this linear equation. I'm going to add 1 to both sides. So I get 3x equal 17. Then divide both sides by 3. And then simplify. 3 divided by 3 is 1. 1 times x is x. I get x to be 17/3. So there's your solution. Now, remember, whenever you raise both sides to an even power, there are times when you may introduce extraneous solutions. So I'm using the word extraneous. So there are times when you're going to introduce extraneous solutions. So these are false solutions. That means that the 17/3 is a solution to this linear equation, but the question is it a solution to the square root equation? Now, in this case it is, and you could check this, but one of the things I want you to remember is when do you need to check when do you not need to check, right? So the fact that there's a positive number on this side, so you have the square root here and a positive number on this side, this is always positive, you don't have to check it. If this was a variable expression, then you would need to check it because if this side, whenever you have the square root by itself now, when the square root is by itself, this side must always be a positive value. All right. So since this is a positive number already, we don't have to check. But let's go ahead and check. I just want to show you how to check this. So if you need to check, in this case it wasn't necessary, okay, because this is a positive 4. But let's just remind ourselves how to check this. So if you want to check, you would say the square root of 3 times, and then x is 17/3. And then you're subtracting 1, and you want to see if that's going to equal a positive 4. Well, 3 times 17/3, the 3's divide out, you get 1 times 17 is 17. So this becomes the square root of 17 minus 1, right? And then 17 minus 1 is 16, so this becomes the square root of 16. And we know the square root of 16 is 4, and that's what that's supposed to equal. All right, so this works. But you didn't have to check it for extraneous solutions because this was a positive 4. It was a positive number. But when we look at the next one, okay, when we look at number 3, that's what we have in number 3. So number 3, we have, let me go ahead and rewrite it. We have the square root, this is number 3. We have the square root of 19 minus 6x equal x minus 2. All right, now notice the square root's by itself, which is what we want. But on this side, you have a variable here. So if I solve for x and this happens to be negative right here, notice a negative 6 and a negative 2 is a negative number. So I could not use it because that's a negative value. So that's why you have to check for extraneous solutions. You definitely have to check for extraneous solutions when you have a variable on the other side. All right, see, that's not a number. That's a variable expression. That's not a numerical expression. It's a variable expression. You have a variable. So you must check for extraneous solutions. All right, now, just like we did in number 2, the square root's by itself. So I'm going to just rewrite this over. And the opposite of square rooting is to square both sides. Notice on this side, I'm putting this in parentheses, and I'm squaring it. It must look like this. Okay? And then the square and the square root undo each other, so you're left with 19 minus 6x equal. Okay, now we have to multiply this out here. So remember, x minus 2 squared means x minus 2 times itself. And then I'm multiplying 2 binomials, so I have to FOIL this out. So x times x is x squared. The outer, x times a negative 2 is a negative 2x. The inner, negative 2 times x is also a negative 2x. And just a reminder, whenever you square a binomial squared, whenever you square a binomial, the outer and the inner should be exactly the same. And then the last, a negative 2 times a negative 2 is a positive 4. And then combining like terms, these are like terms here. They both have the terms, the variable x raised to the first power, so those are like terms. I get x squared. A negative 2x and another negative 2x is a negative 4x, and then plus 4. So this trinomial is now going to go here. So x minus 2 squared is x squared minus 4x plus 4. So notice I went from a square root equation to a quadratic equation. So now I've got to solve this quadratic equation. Now to solve this quadratic equation, we need to have 0 on one of the sides. So what I'm going to do here is I'm just going to bring both of these terms to the other side. Now, I'm going to do it in steps, but you want to get rid of this 19. Right now this is a positive 19. The opposite is to subtract 19. So I'm going to subtract 19 on the left side, I'm going to subtract 19 on the right side, and I'm combining like terms. So I'm aligning the like terms here. So I'm putting subtract 19 under the 4. Then combining like terms, 19 minus 19 is 0, so you get negative 6x equal x squared minus 4x. 4 minus 19 is a negative 15. okay? And so then we get this. So now remember I have 1, 0 here, so this is a negative 6x. The opposite of a negative 6x is a positive 6x. That's the only way I can get 0. So I'm going to add 6x here, and I'm going to add 6x here, okay? And then combining like terms. Notice I'm aligning my like terms. Now combining them, 6x and a negative 6x is 0. And so I get 0 equal, that's what you want. You want a 0 here, equal x squared. Negative 4x and a positive 6x is a positive 2x, and then minus 15. All right, so then I have this quadratic equation. I'm going to rewrite this because you remember we normally like, when we have a quadratic equation, we normally prefer to have 0 on the other side. But it doesn't matter. You could leave it like this. But I'm just going to transpose the sides. So I get this. And now this is factorable. Or you could use quadratic formula. It does not matter, but it is factorable. And so when I factor this, I'm going to get, let's see, x times x is x squared. There's only two possibilities of 15. 15 times 1 or 5 times 3. The one that's going to work will be 5 times 3. All right. And then remember the last sign's negative, so that means these signs in here are going to be different. And you want this term to be a positive 2x. And the only way to do that is for this to be a positive 5 and this to be a negative 3. Now before you go on, check it. Check to see if this is correct. All right, so let's check this. You have x plus 5, x minus 3. So I'm going to multiply this out to make sure I get this quadratic expression back. So x times x is x squared. The outer, x times a negative 3 is a negative 3x. The inner, 5x times x, 5 times x is a positive 5x. And the last, a positive 5 times a negative 3 is a negative 15. Combining these two like terms here, I'm going to get x squared. A negative 3x and a positive 5x is a positive 2x. And then subtract 15, and notice I get that. So what I have here is correct. And now you're going to use a zero factor property. So you have two factors whose product is 0. So one of these has to be 0. So I'm going to say x plus 5 equals 0. X minus 3 equals 0. And then solving these linear equations, I get x to be a negative 5 and x to be a positive 3. And then remember, you raise both sides to even power, so you have to check for extraneous solutions. And you have that variable expression here. And so we have to check for extraneous solutions. So let's go ahead and check for extraneous solutions. All right. And so go back to the original problem. The square root of 19 minus 6x equal x minus 2, right? Okay. So let's just check the negative 5 first. Check negative 5. So wherever we see the variable x, I'm going to substitute negative 5. And just to let you know, by the way, if you did all this work correct, all you really had to do was go to this side here and make sure that it was a positive value. So when I substitute negative 5 and a negative 2 is a negative 7. So this is going to be a positive number, this is going to be a negative number, and right away it's not going to work. So you could have right away gone just to the side here that does not have the square root symbol and substitute negative 5 to see if this is a positive or a or 0 or a negative number. It cannot be negative. All right, so you have to do that, and that's all you have to do. So right away, so this right here is your extraneous solution. All right, so that's not going to work. So extraneous solution means a false solution. So usually you'll see students write extraneous solution and then they'll cross it out to kind of imply that's not going to be a solution. So when you list your solution, you would not include this. All right, but let's go and check this. So let's just check this. So we have the square root of 19 minus 6 times a negative 5, just to show you what I'm talking about, equal, and then we have negative 5 minus 2. All right, so 19 minus 6 times a negative 5. So that becomes a square root of 19. A negative 6 times a negative 5 is a positive 30. 19 plus 30 is 49. So this becomes the square root of 49. And the square root of 49 is 7. Positive 7. Over here, though, that's a negative 7. So notice 7 does not equal a negative 7. So that's why we say it's extraneous. Now let's just check this one. Now, just like we did, all you really have to do, since the radical expression's by itself, the square root's by itself, all you really have to do is just check 3 and make sure that's going to be not a negative number. And notice 3 minus 2 is 1, so you're good. So that right here would be your solution. So you would say x equal 3 is the only solution. Now let's go ahead and check it. I just want to show you that. So let's just check x equal 3 just to show you. So you go back to the original. So the original is square root of 19 minus 6x equal x minus 3. So in place of 3, in place of x, I'm going to substitute the value 3. So I get the square root of 19 minus 6 times 3 equal, and then 3 minus, 3 minus 2. That should be 2 right here. Sorry. 3 minus 2. Well, 6 times 3 is 18. So this becomes the square root of 19 minus 18. 19 minus 18 is 1. So that becomes the square root of 1. And the square root of 1 is a positive 1. And notice 3 minus 2 is 1. And they are equal. So that's why 3 is the only solution. Okay? All right. So notice the amount of work you had to do here when solving a radical equation, and there's a variable on the other side. So there's quite a bit of work there. So you do need to make sure you understand how each of these steps progressed. All right, so quite a bit of work you had to do here, quite a bit of understanding. All right, so that is the key to the worksheet on solving those 3 equations.